good afternoon, and welcome to another session in the DataHour series. We are thrilled to have you here for an interactive learning session. I, Rakshana Vidhya, part of data science team at Analytics Vidhya, will be moderator for this session. For those who have joined us for the first time, a brief introduction about the DataHour session. With the intent to make learning data science more engaging to the community, we begin with our new initiative, DataHour. DataHour is a series of webinars led by top industry experts where they teach and democratize data science knowledge. Now, on to our session today, which is Introduction to Explainable AI. Explainable AI or XAI refers to methods and techniques in which the application of artificial intelligence technology such that the results of the solution can be understood by humans. In this data hour, Avik is going to introduce you to the concept of explainable AI and cover following topics. This is why we should use a machine learning. Where does machine learning fit in? Why? XAI, necessity of AI audit, ethical AI. Before we kick things off and I introduce the session presenter, a quick recap of the housekeeping items. We are recording the session and we will make the recording available in a few days on our YouTube channel. Please use the Q&A section for asking any questions you might have during the session. And as the data hour progresses towards the end, we will do our best to answer them. Also, we will share a feedback poll towards the end of the session, which I request everyone to participate in. Now, on to our speaker today in this session of Data Hour, we have Avik Das with us. Avik has more than 6 years of experience in the analytical field. He has conceptualized and delivered analytical solutions encompassing data collection, integration, cleaning, and pre-processing. He is a seasoned professional in data visualization, predictive analytics, sales forecasting, and scheme analysis. Also, he has hands-on experience with R, Python, Spark, Tableau, Power BI, and many more. So over to you, Avik. The virtual stage is all yours.
Yeah, thanks for supporting it. Let me open my camera. Is it visible? And am I audible?
Yes, you're audible.
Okay. Okay, so first of all, thanks to Analytics Vidhya for giving me this opportunity for this platform to deliver few points on some topics. And it is really honor for me to have this platform because I started my hackathons journey with Analytics Vidhya and Kaggle in the year of 2017, I guess. And and till now, I played a lot of hackathons in Analytics Vidhya, means for sure, and also I scored a lot. Like for example, few special hackathons I scored in 53, 52 rank globally, and in Kaggle hackathons I received the gold medal. I'm a gold medalist in Kaggle as well. So that is really honor that where I played the hackathon. They give me the platform to deliver some speech on some topics. That is like today's explainable AI. So anyways, so before starting, as I can understand from the polls that there are a lot of people are means very fresher in terms of in data science, but also might be there are people I don't know, but it's possibility that there are people who are 6, 7, 8, 10 years of experience, but as they are not in data science, and that's why they marked as no experience or 0 to 3 means 3 years experience. So that's why today, before jump directly to explainable AI, I will first do some very brief idea or understanding so that you guys can have the idea that why and what and where we are going, and what is the need of this talk or on this topic. So okay, let me start and let me share the screen first. Let me know if my screen is share it. Just a minute. Share this. Uh, I feel my screen is visible, right? Okay.
Yes, it's visible.
Yeah. Okay. So, what is this? Okay. So, first of all, is that what is I'm not going to ask us explain that what is machine learning. I am not going to say. I'm just trying to give you a pre-read because there are so many freshers as well might be. So uh, let me quickly go through this thing. The step data. Okay. So first of all, machine learning. The thing is that we all know about machine learning, and that's why we come to this platform and we are joining in this session to understand about more and more about this machine learning. So before start, we will let's have the let's have understanding that what is machine learning. Machine learning is nothing but you can say as a human brain, right? So the human brain is also a machine. Yes, you can think about like this way, that whatever we are seeing, whatever we are collecting the data or information from the external factors, it is coming to our brain, and then it will process and do some algorithmic calculations, and then analyze it, and then brain will uh, mm, uh, basically pass the commands to our different cells or neurons to act accordingly. So like for example that when we are when we are going to means buy something in the shop or market, uh, how we can uh, uh, say the shopkeeper that okay, this is the 10 rupee note, and this give me the product, although might be the product price tag is not there. So it is basically that previously the historical data inform our brain that the price of this product should be or might be 10 or more than 10 rupees INR. That's why you should pay if there is no price tag. So that's a very simple thing, and that's and whatever we are giving the shopkeeper, or whatever we are delivering, that is the prediction based on our historical knowledge. So that is a very simple term in machine learning, I can say. Okay. Now next, say for example that you plan to buy some car, and you have lots of data, like for example there are lots of cars in the market, right? And then you feel that okay, so how can I choose that which car is very suited to me? So might be some when you visit to the market or the uh, uh, delivery center. And there are lots of sales team or salesman, and they are giving you multiple informations and about multiple cars that is available there right now at that time. And now your brain is basically collecting a lots of information at a time, and it's very difficult for you to analyze the data and 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 take the decision that which car you should basically buy. Now, there are few informations might be some known data. There are few informations might be unknown, very, very unknown to you. So how can you analyze? So at that time, the experience will help you to analyze the all data, and also the experience inform you that okay, whatever the informations are coming, might be there are few informations which are noise, so just exclude them. And then out of those included data, you need to then divide or do the clustering about the data points, that what is your demand, what is your financial means support or financial thing you have in mind, that this is the budget, and few human factors. So human factors means the family needs, family, your spouse or your children or your means parents choices and all, and also your own choices. And based on that, you start clustering on different basically cars. So basically, like this way, you can choose that, okay, out of the, you can see this two car, I can say that, okay, this car might be little low price, but it is adjustable to my need and also my expectations and my satisfaction. And that's why I will buy this car, not this car. So like this way, means our human brain is working, as well as our machine learning or machine learning models are working in this area. Now, this is very significant information for every one of you, and even whoever right now present in the market or in industry, that this is the, you can say the timeline, or this is the milestone of AI transformation. You can see that here I mentioned three categories. One is experimentation, second one is multiplied innovation, and third one is autonomy. So what is the basically the difference, right? So basically there is no as such difference, but if you think about that, that uh, previous days we have the knowledge or information that how to predict the data, how to use the data, analyze the data, but it is more in manual, and sometimes we did it based on our intuition. Now, after 2007 or 2000, after 2000, let's say, companies are growing and thinking that, okay, this data is very important and how to use it. But before use the data, we should store the data. So very previous days or earlier days, the data are basically stored in manual format. Now they start, and it is very hard to retrieve. So they started to store the data in cloud, in mobile, social data, and whatever we are saying that Azure, data lake, data warehouse, and they started scaling the database. Now, means once they have the data, so right now they have the data, they have all the informations or the raw informations within them, within their warehouse. Now industry is thinking that, okay, now we have the information, we have the raw data actually. Now how to process it, how to use the data. So to use the data, we should have the proper informative information. We should do some pre-processing, data augmentation, and something calculations, you can say, which will help us to make the strategies, to make the decisions. Then they think of machine learning, that, okay, if we can create some models which is based on statistical calculations and mathematical calculations, which will help us statistically and logically, that based on this historical data, what should we do? Like, for example, I build a flu-based model in 2019, just before the flu camps, in means in world, that is basically COVID. COVID is nothing but a influenza-like virus actually. So at that time, what we think that, okay, we have 10 years of data. Now, based on the 10 years of data, how we can help any organization to take the decision that how they produce the product. So based on that, it's very difficult, because for that organization might be the data is very very biased. So we should have the data from other organizations. Also, we have some external factors, like, for example, the weather, the region, then different type of food habits of different area of citizens. So like this, we collect multiple data. Even we collect the data of the, data from WHO. Now, based on that multiple data points, we build a model which will help us to predict not very much, but at least 2 to 3 months that, okay, this might be the range of flu-like virus, flu-like symptoms of or flu-like disease in this area based on multiple region like Australia, like India, like US, like this way. And then we go miss more deep dive. And when we go from country level to regional level, then the model will fail. And why basically it failed? Because of less number of data points. Then this is the example that if someone thinking that if I build a machine learning model or AI model, it will do anything. It will be a magic for everyone or anyone. That is not actually. So until and unless you should provide a very processed and accurate data, no one, even the human, can't give you the correct information, right? So uh, that thing we need to keep in mind while building any models. Now, the data is coming to our model, and then we give the information or predictions, and that's why we are here. That okay, right now, AI, IoT means in the sense, for example, Zoom is using IoT devices to collecting data from their different cars, that how the cars are managed, how the brakes and accelerators are going for different drivers, and they score different drivers based on those categories. So like this way, they are using the data and enhancing the customer experiences a lot. Now we are going toward the more autonomous system that is basically exponentially AI or quantum computing and biodigital computing, and there is lots of different things are there. So this is the very simple transformation timeline you can see for the AI, machine learning, whatever term you can use. So now we have data, we have multiple segments to understand that, okay, we have pharmaceutical, uh, we have aviations, then agriculture, and lots of other segments are there. But there are totally a very simple understanding or very simple, I can say, logic that might be there are multiple domain, might be there are multiple things are going on in the market, but we have very simple one line, I can say, one line thing that is basically we need to understand. We need to keep in mind always that before jumping to in a machine learning thing or data science thing or AI thing, this should be in very properly or accurately maintained, or we need to think of that how to use it or how to do this logics or these things. Okay, so first is descriptive. So first I say descriptive. So descriptive basically what happened. Like for example, that if there is a flu, so uh, the question is what happened. What happened is the basically flu. So based on that, we can analyze. We can analyze that the flu is there. So what are the other factors that will help us to analyze more accurately about flu predictions or flu symptoms or like flu futuristic training basically. Okay. Now then after descriptive we have diagnostic. So diagnostic, what it will say, diagnostic will say that okay, so this I know there is basically flu in the market or in that area, but why it is happening. So to know the answer of that question, that why it is happening, we need to collect more data from external factors. That for our example, you can say we collect the data from WHO. We collect the data from Google Analytics. We collect the data from social media. And from social media, we have all multiple forums are there from where we are getting lots of information that flu is happening due to the season change, due to some food habits, because in some area flu is not there because of their good food habits. So like this way, we can diagnose the issue that why it is happening. Now the next thing is that predictive. So predictive is that okay. So we analyze that what is happened, why it is happened, but what might be happen. Basically, what is the future? So in our case, that I mentioned, that is the diesel price. So diesel price is basically the see in overall all over the world, the price of oil is increasing rapidly due to some external factors. So we need to understand, or the company or industry need to understand that what might be the oil price in coming days, because based on that all the industries will create their budget plan, we create their production means production plan, sales plan, and there are lots of many more like man force planning as well impacted due to this price increase. So that is the predictive. Now the last but not the least is that prescriptive. Prescriptive is basically that okay, uh, this is my prediction, this is the data, and there is a short note which will help to analyze or you can say it will take as a um, decision or suggestion that how you can handle this situation. So you can say action. It's basically a action based on forecast. No, so in our case, if the forecast of the volume is coming low for next month, what steps should be taken to improve the sales? So that is the recommendations. You can also say that is the prescriptive. So this is a very three high level cluster that everyone know, that unsupervised, supervised, and reinforcement. So I know there are lots of people here who aware of this supervised learning, unsupervised learning, and also few people for sure know about reinforcement card, reinforcement learning. Basically, reinforcement learning, I can say the Google car. You all have the idea that there is Google car, and it is basically using this algorithm about reinforcement. So till now, anyone have any question? Because now I'm going to explainable AI. So before jump into the explainable AI, anyone have any questions? Let me open my chat window. Rajesh said, please go back to the previous slide. Okay. So do you have any question? Can you? Okay. Rajesh, do you have any question in this slide? If not, can I proceed? Okay, thank you. Let's proceed to, okay, how many people are very people are there in this audience that who love the cats? I'm not showing cats like this way, but that's a evening joke anyways. Okay, let's see the very small video for you guys. Is this audible, I guess, right? So you can see here that how there is someone who is basically giving the foods onto the plate to two different cats, black and white. And okay, this is not audible. Okay, let me check what is the settings. Okay, let me do one thing. I guess this share advanced VD computer audio. Okay, yeah, computer audio is not there. That's why. Okay, anyways, if the voice is audio is not audible, that's not a problem. You can see the written things that whatever is written there. Let me uh, explain that what is happening. Okay, so basically you can see these cats are basically pressing on the bells, and that's why they are getting the foods. Okay, so no, now you can see here that this cat is analyzing that how this white cat is ringing the bell, and if the white cat is getting more food, might be means the black cat is thinking of that, and that's why after some time the black cat will ring the second bell. So you can see here. Let me see that when the time will come. Okay. See, so this black cat think of that, okay, might be it's possible if I ring this bell rather than my bell, I might get more amount of food. So that's why it is just a very simple example of reinforcement learning that cat or any animal is, or any human beings are basically following. So reinforcement learning is nothing but like that. What you are feeling, what your organs or internal neurons are thinking, and then behave or act accordingly. So sometimes it's also happened that you say that I'm very angry. So it's not like that you are angry, you are impacted by the external factor. So to be very calm, to be very happy, you always need to keep all the external factors out from your feeling or your thought process. So like this way, you will keep yourself more calm, more focused, and more energetic about your work, your target, or your goals. Majorly, I feel more than 80-85% might be the people in the world are basically impacted by the human factors or the external factors. So also I am within that 85% might be, but the main point is that if we are following few things that we should not impacted by the external factors, then every one of us will be a very intelligent, very uh, uh, good in time management, very fantastic in strategic management yeah, to achieve our goals. Because these external factors deviate us to grow, to go after our goal or to achieve our goal. So we should not allow the external factors to uh, impact us. Okay, now explainable AI, that is XAI. Now, what is XAI? XAI, you can say that the term is mentioning explainable AI. Now, let's take our examples. Uh, so I am right now very angry. Okay. Now the question is, why I am angry? There might be some reason. Now, if based on some machine learning model, like sentence analysis, textual or NLP model, we collect the information from my historical data that This is the reason I am very angry right now. That is okay. I am very angry right now due to this reason. But why I am angry? It is not the answer that why, based on that data, based on that information, the model is saying that this informations are impacting to me. Because this information impacted to me, but this information might not impact my other colleagues or my friends or my parents or my spouse or my children. Now, why this information is impacted to me? That is the answer to explain that what are the series of connection which directly impact me, not the other people. So that's why we are going to understand explainable AI, that why it is needed. So basically, this the explainable AI, you can say that we aware of deep learning, we aware of neural networks, we aware of simple classical machine learning. But these things are basically, you can say, very unpredictable, because no one aware of that what is going on behind the scene. It's like movies, Hollywood movies, that we are seeing that the Terminator is fighting with another Terminator, but actually in behind the scene or in the back screen, there's something else is going on, and that is called animations. Now, deep learning, neural learning, or classical machine learning will only be helpful to us if we can understand that what is going inside that thing. So there is no need to throw this deep learning baby to the water, which which is very deep, and we even don't know that how deep is it. So that's the one. Second point is that US Defense Advanced Research Project Agency, that is DARPA, basically noticed the need of explainability of for deep learning and other more complex algorithm to produce this explainable AI solutions. And basically they are one of the institution who basically started funding for this research, that how we can explain that what model is doing, why model is doing, and based on which data points model is doing. These are the questions to answer to start the research. Rajesh, we are the most happy people. Okay. Okay. So basically, now DRPA basically describe AI explainability in 3 different parts. Okay. So basically, the first point is that prediction accuracy, which means models will explain how conclusions are reached to improve future decision making. That is one. So the second point is that decision understanding and trust from human users and operators, as well as inspections. Third one is that traceability of actions undertaken by AI system. Now, let's go little deeper. Let me go to the next slide. So, why these 3 things are needed? So, from the previous slide, we come to know three basically terminology. One is transparency, second one is interpretability, and third one is the explainability. Transparency is basically, let's say there is a financial model or financial prediction. Now, your model is basically predicting some financial data, uh, which will help to do some financial audit. Now, if your data or your model don't have the answer as the evidence that why your model is giving this data, then how the financial audit company or the financial audit uh, audit, audit group will understand that how the data is coming and how to audit, because those data is generated by your model, not from any human this factor. So that should be a transparent understanding that okay, this is happened due to this data points. That is one. Second is that interpretability, or you can say traceability. Like for example, I have the sales prediction, but the sales predictions certainly it's very high. Now your manager or your product head will go into deeper and identify and trying to identify that why the sales prediction is very high. Now, how he or she can understand that? He or she can go part by part data points that okay, my model is giving this prediction data based on this amount of data points or historical data points. And those data points are basically coming from external factors, not from any automatic machine or any other model. So those informations are valid informations as evidence, and based the calculations of all the data points which we are getting from the model, those are the evidence of our prediction. That is the interpretability or traceability, and similarly the explainability. Explainability also coming to or incorporate with the interpretability thing, which will help us to explain the senior management or like says the industry or any other COE people who basically who basically responsible for any strategic decisions. So here you can see that yes, machine learning is nothing but a black box where even the designer cannot explain why an AI arrived at a specific decision. This is the main reason. We need the AI audit, or you can say explainable AI. Now let's see a simple example that I basically mentioned here to understand more closely. Let's see here. We can see this is our training data. This is our learning process, or you can say our machine learning model. And this is the input, that is the test data. And doing some calculations is giving the output. Now the question arises like this three, that how can I find the errors? Can I trust this? And why so expensive? That I say that certainly a very high in sales. So basically why it's very high. Similarly, why it is so expensive? That is the question to the user, question by the user. So these three questions are basically based on transparency, the ability to question, and the ease of understanding. Let me go to the next slide. That why is explainable AI so important? Now see, here we have a deployed machine and the user or you are going to ask that what is going on there. That is the model. Now we come into the picture of the explainable AI, that explainable how explainable AI is incorporated with the workflow. Now this is the new process, new learning process, and there we added the explainable model. So this explainable model is functioning like this way, where we have added one more explainability layer, which will give us the explanation that why the house price is very high. This will use as a evidence of our prediction, and also the trust to the industry, to the user, that okay, whatever the model is coming, we trust it. Like for example, you are buying something from Amazon, it is sometimes means force you to think that whether the product is trustable or not, and whether uh, uh, spend that amount of money is means basically worth or not. So at that time, what you people are, even I also, the normal thing we did, uh, that is going through the reviews, going through all the review comments, what reviewers are giving, right? Means means good, bad, what are the pictures they are posting, or whatever the videos are there. Based on that, we analyze the data, and then it will increase our trust, or it will help us to take the decision that whether we should trust that product or not to buy it. Explainable AI is doing the same thing, which will create the trust that whether industry or the user will get or will use this product or not. Okay, now let's come. The next point is that there are few packages which we aware of, which will help us to do some explainability of our model. Like first one is that basically SHAP. SHAP, the full form of SHAP is basically shapely additive explanations. It's basically explain a lot of information from the model. For your understanding, let me show you one example. I guess it is visible to you guys. I have created one for you all. Okay, so it is a very simple breast cancer I have created for you all. Uh, then we have used here the simple XAI model as a classifier, and here we can see that okay, the accuracy is of this model after getting the score is 95.61%. Now question is that this model is giving me that 95.61% of accuracy. Is this accuracy is correct? Because we even don't aware of this thing that this accuracy is based on the biased data or unbiased data if we are not following the bias unbiased analysis, right? So just a question. There is one question. Can you back to the previous year? Mary, sorry, I missed your message. I will get back to you after this coding thing. Okay. Uh, okay. So basically, this is the question that with this model giving me the accuracy based on which data is a biased data or unbiased data. Now, coming to that point is that SHAP. Now, here I use few SAP mechanisms, few SHAP functions, which will basically use my all the informations, all the data that we have imported here on the model we used, and the prediction we get using all this thing. Sorry, using all this thing, SHAP basically start creating of the explanation or the trust or the evidence that why. Now you can see, let me go very simpler one, that is first one. So here you can see the SHAP value impact on the model input, model output, and another is the feature value. Now we all can say that okay, we have the mechanism or algorithm or process which will help us to understand that what is the impact of different parameters or attributes on the model overall. That we did like heat map, correlation coefficients, and so on and so forth. There are lots. But to understand that is accurately, that how good, how bad the attributes are impacting to our model, this graph will give you the answer that uh, that this is the very low. That's when these parameters are very impacted, but in a very low way. And what is the deviation? What is the variance? Because it shows that there are multiple data points are there, and like for example, the mean concave, concave, worst concave. Let's say something else. What is that? Worst texture. So this worst this texture data point is impacting highly, but how scattered it is, how biased or unbiased is it? So like this way, there are lots of parameters, lot of visualizations this SAP model will create to help you to analyze more within the data points. I will give all the question answer after some time. Please give me some time. Okay. Okay. So this is the thing. Now next one is the line. So line, let me just a minute. So line is basically, you can say, local interpretable model agnostic explanation. So it is the full form of line. But let me explain line a little bit later, because there's another slide which will give you the all the informations. Next we have SPASH. You can say SHAPAS, you can say, but you can say SPASH as well. That is different thing. Okay, so SPASH is basically the combination of line and SHAP. Now we have the next one, is ED. ED is basically the explainer dashboard. Nothing else. It is an explainer dashboard only. Next we have DALX. Next we have let's see, EBM. EBM is basically explainable boosting machine. We also explain it after some time. Then we have ELI5. So these are the very few explainable AI based models that is right now available in Python market. But what I can suggest that we can use our own model or our own packages, that like I did. I have my own packages which will basically help me to explain that what is going on within the prediction, within the different clusterization. And that is basically a very excite you as well, that okay, that whatever explanation I am getting, I even trust that package because I build it. I have end-to-end logic understanding that why it is giving me this explanation, because ultimately these packages are also created or built by someone else, and who knows, after some years or some months, someone asks that okay, do this SHAP or LIME or EB or DALX is giving us the correct answer or not? What is the evidence that what they are doing? Even we are not aware of this internal information about these packages. This might happen. So better to create your own packages, and even more compact way, more DIY format way or modular way, which help you to give more enhanced information as evidence to your customer, to your management, to your company. So let's come to SHAP. So basically, if you say that what is SHAP? SHAP, I say that SHAP is nothing but explainable module, which is basically, you can say that is a model of agnostic framework. SHAP basically helps you to understand the magnitude of impact and direction. Like for example, you can see there are 4 attributes, and these 4 attributes help you to understand that what is the impact it is giving to your model. and what is the detection, like we did in scenario analysis, that how positive is it or how negative is it. Like this way, it is giving you the explanation. Now, next we have also understanding that this is basically a great starting point for any newcomer or data scientist people to understand how to create the model. Even you can go through all the modules that is created within the shell that is available in Python library. Now, the creative aspect around using these values to generate more engaging visualizations and insights lies within with the data scientist basically, and this more engaging visualization also help your customer to increase the trust on you. Now we have next is Lime. Lime is basically, you can say, local local interpretable model agnostic explanations. Lime helps to explain predictions for tabular data, images, and texture and text classifier. Lime basically tries to give a local linear approximation of the model's behavior by creating local surrogate models. Like, for example, it will get more augmented model, which will help sorry, which will retrain the data and then give you the more information that, okay, if these are the other models, that how these models will behave. Now, how it is work? It is basically, you can see in the slide that say it will work like this way, that select your instances of interest for which you would like to have an explanation of its black box prediction. Then I'm not reading these points, but you can see from documentation, it is very highly needed to understand before this live this package. Then we have Spash. Spash is basically, you can say, this package compiles a various visualization around SAP and Lime explainability. It uses SAP or Lime backend to compute the contribution. Spash relies on different steps necessary to build a ML model to make the results understandable. It works for regression, binary classification, or multi-class problem, and is compatible with many models like CADCOS, Execute, Light LGPM, Sklearn, SVM, linear models, so on. Okay. Now you can see here in the right side that this is a very high level process flow, that how the Spash is basically working. First is the data preparation, then is feature engineering that we all do, model fitting, model evaluation, model understanding. But Spash is at the end, it is create the explanation that whatever the model understanding is, that Spash will create the evidence from that data points. Now, next we have a very simple understanding that how Spash monitor will work. Here you can see that this SHAP will have different feature importance, local explanations, indexes, threshold, and then few charts of contributions, which will help you more enhance your evidence or more enhance your understanding toward the predictions and your model building or model fitting. Now, explainer dashboard is not like, you can say, the model explanation, but yes, you can use use this as a explanation, because this explainer module because this explainer module or this package will help you to give the data more precisely. Like, for example, let me show you quickly. There you can see that once you import the data, it will self-create some graphical charts, some accuracies, some other statistical calculations, feature importance and all, to give you more enhanced understanding about your data set before creating the model, before running or fitting the model. So like this way, you will have a pre-understanding of your data set and how your data will behave, how biased or unbiased the data is, or if the data is follow some trend or not, and if the data has some seasonality, some seasonality or not, Like this way, you can understand and you can create the model accordingly. Now we have the explainable boosting model. So explainable boosting model is this, that basically you can say it's an open source package from Microsoft that has a module of class box models which enable explainability based on the idea of additive models. This EBM changes the training process from training a decision tree on all features to a decision tree with one feature at a time. Like for example, if you have a decision tree model, it will use all the features regardless of how important is it, and give you the prediction. But EVM, how it will work, it will go part by part, attribute by attribute, and then create the accuracy and values which will help you to understand that, okay, if this is the features or these are the features, then why these features are more important, and what are the interdependency of features. So like this way EVM will work. Okay, so let me go to very next part, that is the simple process flow of EVM, um, that how it will work. Okay, now we come very end of this session. What is AI? It is ethical AI. So we know about XAI, that is explainable AI. Now what is ethical AI? Now, for example, why ethical AI come into the picture? So ethical AI, basically, let's give you one example. An autonomous car is a vehicle that is capable of sensing the environment and moving with little or no human involvement. That we all know about that. So for this vehicle to move safely and to understand its driving environment, an enormous amount of data needs to be captured through the sensors, and it will act accordingly. That is also aware of that. So these are then processed by the vehicle. Okay, fine, very good. It is working very good. Now let's go more deeper. The autonomous car must also undertake a considerable amount of training in order to understand the data it is collecting and to be able to make the right decision in any imaginable traffic situation. Now the question is about moral. So moral decisions are made by everyone daily. You, me, anyone else, right? That is the moral decisions. Strategic decisions on time, which might not be created previously. Now, when a driver chooses to some on the brakes to avoid hitting some person or something like that, they are making the moral decision to shift the risk from the pedestrian to the people in the car. Now, imagine an autonomous car with a broken brakes. The brake is not working, right? So going with the full speed, and it is not able to control the speed, and suddenly the car seeing in front of the road, there is some person who is grandmother, and the grandmother is grandmother is who? The owner of the car. Now what the car will do, what is the decision it will take? Because for the car, the person which is in front of the car, it is important, as well as because it's a human being, as well as it is more important because of the owner as well for the life. Now these are few moral decisions that still very questionable, very argumental, and very you can say that there are a lot of arguments is going on that how it will work in this area, and that is still on discussion. And that is why UNESCO has embarked the first time to develop a legal and global documentation on the ethics of AI. So these are the things that why ethical AI is very highly needed. That who would you choose, the grandmother or child, or do you think there is only one right answer? That is not. So like this way, it is a very confusing situation. It will happen, right? So that's why we need the ethical AI that has the, so now the AI has the potential to use in in good purpose or in not good purpose. So if it is used ethically, AI can help the organizations to operate more efficiently, produce cleaner product with lesser noise, reduce harmful impact, increase public safety, improve human health. That is the ethical thing. Now, if the AI is being used as a every purpose, then it will do disinformation, deception, human abuse, and political separation, etc. So these are the things basically very uh, argumental and think of AI, that why and how we can manage these things. So that's all, I guess, to uh, the whole AI, explainable AI, and the ethical AI thing. So I guess that's all from my side. Now, if anyone have any question, let me go through the questions as well to quickly answer. So someone says the question that how explainability is different from interpretability. So it is actually uh, uh, not very different. It's like two sides of one coin. So explainability you can say as a superset, and interpretability as a subset. Now, Mary has a question that, can you go back to the previous? Okay, sorry, I missed it. So do you have any question till now, Mary? You can ask quickly. So now Dr. Sarita has a question that is XAI is prescriptive? It is not actually, because prescriptive is different thing and XAI is different thing. XAI is basically the evidence of this thing. Okay. Um, Now, Gautam is asking, is there any explainability provided by XAI on why model performed badly? Yeah, I already mentioned all the models that is there. So you can go through that. All the packages is that. Rohit, is that any explainability library supports object detection? There is also answer already. So you can go through that. Okay, that's, I guess, lots of answers I given. Anyone having no question or any question, we can spend two to 3 minutes more and then we can close. Raksha, Shrestha, I guess
Yes.
I am done from my.
Okay. I think there is one more question in the chat section. I will read it out for you. This is
Okay.
how to figure out, yes, how to figure out the accuracy of the explanations. Also, will the data scientist be accountable for the explanations of XAI?
Can you please repeat the question once again? How?
Okay. How to figure out the accuracy of the explanations?
Okay, so for the first answer is that the question is wrong, because explanations is not responsible to give you the accuracy. It is responsible to create the evidence that why you have this accuracy.
Okay, thank you so much for answering.